Rate of change and slope. Rate of change shows the relationship between two changing quantities when one of the quantities depends on the other. The following formula is the one that we will be using to find the rate of change. And this formula is the change in the dependent variable, which we are normally going to call the y variable, divided by the change in the independent variable, which we usually call the x variable or the input variable. Okay, so the change right here is going to mean difference, so we're going to subtract two numbers for both of those. And that's how we find the rate of change. Now we need to be able to find rate of change in several different ways depending on the information we are given. So if we are given a table, basically it's just a set of points. We have the point 8, 200, the point 12, 220, 16, 240, 20, 260. It's just a set of points, and then we have our x variables, which is independent, and our y variables, which is the dependent variable. Okay, so we should be able to find our rate of change using our formula, the change in the dependent variable divided by the change in the independent variable. So the rate of change is going to equal the common difference here. So we need to first verify that this is the same difference between these two. So we added 20, we added 20, we added 20. This is how we did it before. And then from 8 to 12, we added 4, added 4, added 4. So they are a common difference, so we can find a rate of change. So we're going to find change in dependent over the change in independent. So my dependent is, so once you realize they're all the same, then you can pick any two. It doesn't really matter. So I'm going to pick 220 minus 200, and I'm going to divide that by 12 minus 8. Or you don't even have to do that work because we already did that, finding 20 and 4. So we know we're going to have 20 over 4, and because they were both adding, they're plus 20 plus 4. 20 divided by 4 is 5, so my rate of change is 5. Now we want to find the rate of change using a graph. Okay, so looking at this graph, we're going to want to find some key points, and then we find our change in our x and our change in our y. Okay, so we're looking for the rate of change. So we're going to do our change in y over my change in x. Alright, so first I'm going to pick some points that I know. So I'm going to pick the easy ones because I can see that it's crossing right here at, since I'm going by 2s, 2, 4, 6, 8. So that is the point 0, 8. So you should mark that. And then another point that I can see is right here. It appears to be at that point right there. So I'm going to mark that point as 1, 10. Okay, now I don't have to go any further than that because I can very clearly see that this is a line. And because it's a line, we know that the changes are all going to be the same. That was the good thing about it. So my change in the y's, so I'm going to be looking at my y's right here. The change in those. So I'm going to take 10 minus 8, and then I'm going to look at the changes in my x's. 1 minus 0. Make sure you match them up properly, the 10 and the 8, and so the 1 has to go first on the bottom. So that equals 10 minus 8 is 2, 1 minus 0 is 1, so my rate of change is going to equal 2. Final answer. The rate of change can also be called the slope. Okay, so when we're talking about the slope, we can mean several different things. We mean the change in the dependent variable divided by the change in the independent variable, which we already talked about. Or we could have the rise over the run, so that would mean how much it goes up or down divided by how much it goes left or right. Okay, so we just do a little division problem, rise over run. Always think about rise over run. Or we could think about it as an equation, which will actually be what we need to do in the future problems, and that would be y1 minus y2, the y's, changing the y's, divided by x1 over x2 minus x2. Okay, the change in the x's. So this is the equation we're going to be using, and it's essentially the equation we use every time, but these two are basically just what it means. It means we're going to take the change in the up and down divided by the change in the left and right. Okay, so what we're going to do now is to find the rate of change given a couple points. So we want to find the rate of change between -1, 0 and 3, -2. So this is my x, and this is my x, and this is my y, and this is my y. So here's x1, y1, x2, y2. Alright, so now I'm going to set up my formula, which is going to be y1 minus y2 over x1 minus x2, and solve. So put in my numbers. So my y1 is 0. So I put in 0. Minus my y2, which is -2, so put in -2, over my x1, which is -1, and my x2 is 3, minus 3. So now I solve this. 0 minus negative is going to be a positive 2, divided by -1 minus 3 is -4. So my slope, which I'm going to call m, because we generally call slope m, equals 2 divided by -4, which is -1/2. So that is your final answer. So from now on, we're just going to call the slope m, but it's the same thing. Okay, so for my next one, I have 1, 3, and 4, -1. So my x1 term, my y1 term, my x2 term, and my y2 term. Okay, so my formula, I'm going to write my formula so I remember it. y1 minus y2 over x1 minus x2. So y1 is 3 minus my y2, which is -1 over my x1, which is 1, and my x2, which is 4, minus 4. So when I solve, 3 minus a negative is going to turn to a positive, so 3 plus 1 is 4 over 1 minus 4 is a -3. So my m, or my slope, equals -4/3. And I'm going to make sure that's simplified, and it is, so that's my final answer. Now, slopes of vertical and horizontal lines are special. If the denominator is 0, then the line is vertical, and we call this a slope m is undefined. Okay, so if it's a vertical line, the slope is undefined. Now, if the numerator is 0, then the line is horizontal, so my slope, which is m, is 0. Okay, so that's the difference. If it's horizontal, it's 0. If it's vertical, it's undefined. So just remember that horizontal goes left and right, and vertical goes up and down. So we want to find the rate of change in these next couple points. So we're going to use the same formula, m equals y1 minus y2 over x1 minus x2, and then we're going to put in what we know. We're going to call this my x1, y1, x2, y2. So my y1 is 2 minus my y2, which is 2. My x1 is negative 3 minus x2 is 2. So what I get is 0, 2 minus 2 is 0, over negative 3 minus 2 is negative 5. So in this case, my numerator is 0. So that means that my slope, 0 divided by negative 5 is 0. So my slope is 0, and it is a horizontal line. So there's your final answer. And the next one, again, we're going to start the same way. M equals y1 minus y2 over x1 minus x2. Okay, so put in what I know. This will be my x1, y1, x2, y2. So my y1 is negative 2. My y2 is negative 1 over my x1, which is negative 2, and my x2, which is minus negative 2. Okay, so now if I solve here, negative 2 minus 1 is a negative 3 over negative 2, double negative changes to plus, plus 2 is 0. So I have denominator of 0. Okay, so if you try to type this into the calculator, you can't get it. So m is undefined. And it's a vertical line. So that is your answer. So undefined is not the same as 0. So keep them separate. And that's your final answer. So those are your notes over rate of change and slope. Go through some practice problems. Make sure that you're starting to understand some of this slope and rate of change and the terminology we use, because in the next one we're going to go deeper and understand more of what this means. Go through some practice problems and then you'll be ready for your quiz.